All right, so we're still doing 10-2 circles. Our objective is still to use and determine standard and general forms for the equation of a circle and graph circles. And let's get to our one last example, example 4, which is to write the equation of the circle that goes through the following 3 points. You can define a circle by 3 nonlinear points. In this case, those points are 5, 3, -2, 2, and -1, -5. So, what I'd like to look at first is what it looks like when we just give ourselves a small graph of these 3 points. So 5, 2, 3, 5, 3 is there, and -2, 2 is there, and -1, 3, 4, 5, -1, -5 is right there. And what we want to do is we want to have a circle that touches all 3 of these points. And that's kind of difficult to make, but I kind of go up here a little more, and it winds up looking something like that. And when you're given 3 points, this is the first thing you should do. If you don't draw it first, you are skipping an opportunity. And that opportunity is, if we had had 2 of those points that are exactly opposite, that we can tell are exactly opposite and go through the center of the circle, then all of this gets a lot easier, right? We just take the 2 that are opposite, like let's say if we had the 2 here or something like that, take the 2 that are opposite and figure out that distance, cut that distance in half, and we'd be able to figure out the center. And it would get a lot easier because of it. But should be fairly obvious that we don't really have that going on here, right? So this is the most difficult of any scenario. And the way you deal with this is you say, okay, I have the general form for the equation of a circle as, in general, x squared plus y squared plus capital Dx plus capital Ey plus capital F equals 0. We had that yesterday. Okay? And what you say, what you do is you say, okay, I have an x and a y. I have, let's say, x1 and a y1, an x2 and a y2, an x3 and a y3. 0, 9, future. Yes. Oh, yeah. Exactly, you're going home. So, since we have these 3 sets of x's and y's, what we can do is make a 3 equation system. Yes?
Why are there 3 x and
Because we're given 3 points.
Oh.
Okay? So, given these 3 points, we can set up a 3 equation system, which you could go and solve by substitution or elimination, but that's going to be a little more difficult. What you can do, now that you know how to do it, is put them into a matrix and simply solve that matrix. So here's the way we'll do this. We'll plug in x's. So I've got 5, is my x, 3 is my y. And every time I get to an x, I'll put 5. And every time I get to a y, I'll put a 3. And that's one equation. Now we'll have to work with it a little bit, but that's an equation. Then I move on to the second one, same thing. Every time I see an x, put in a negative 2. Every time I see a y, put in a 2. So there's our second equation. And finally, our third equation, every time you see an x, you put in a negative 1. Every time you see a y, you put in a negative 5. And then what you need to do is clean these all up. Okay? So the first thing we're going to do is figure out these sums, and then we're going to subtract them to the other side so that we have 5b, 3e, 1f equals so on, and so on and so on. So that's our next step here. So 25 plus 9 is 34. So we've got 34 plus 5d plus 3e plus f equals 0. And then 4 plus 4 is 8. So this is 8 plus negative 2d plus 2e plus f equals 0.
Well, I'm saying you're going too fast.
Yeah, let me finish this last one. I'll give you a chance to write the rest of it. 1 plus 25 is 26. So it's 26 plus d times negative 1 is negative d, plus negative 5e plus f equals 0.
Why is it negative 2d?
Because d times negative 2. Because x is negative 2 in the second point.
You want to say minus d?
You absolutely can, yeah. I don't, just because it helps me keep track of what's positive and what's negative, to put them into the matrix. So that's why I don't do it. But yes. I'm just going to erase the top so we can kind of keep going. So now we've used those points, we don't really need them anymore. I'm going to keep the picture of the circle up though, because it'll be helpful as we keep working. So we're going to take this and start working up here. I can wait. Sorry. Everybody good? Yes? Okay. So now, the next thing we're going to do is do minus 34 on both sides for this one. Minus 8 on both sides for this one. And minus 26 on both sides for this one. And this will get it into the form that we need in order to set up our matrices. So we'll have 5d plus 3e plus f, and this one will equal negative 34. 0 minus 34 is negative 34. Then the next one will be negative 2d plus 2e plus f, and this one will equal negative 8. And then finally, we'll have negative d plus negative 5e plus f, and that one will equal negative 26. Everybody understand where those numbers came from, why they're where they are now? Everybody at home understand? So, we're okay with this, right? Everybody's good? This allows us to set up a matrix system. And then we can put that matrix system into Metacalculator or some other matrix technology and use it to solve for D, E, and F. So we'll take from this, from this, we'll set up a matrix A, which will be 5, 3, 1, negative 2, 2, 1, negative 1, negative 5, 1. Well, there's going to be a matrix A. Remember, there's always AX equals B. So times our matrix X, which will be just D, E, and F, are variables. That's always what the matrix X is. And it will equal matrix B, and matrix B is always our answers, negative 34, negative 8, negative 26, matrix B. And just maybe a reminder, this is a 3 by 3. This is a 3 by 1. This is a 3 by 1. And if you recall, in order to get matrix X, we had to do A inverse times B. So the way you would do that is to put A and B into Metacalculator or some other matrix technology and do A inverse times B. And I have set that up for us.
And we would plug in what's in the matrix A.
Right, matrix A, you would plug in matrix A and B, and you would have these matrices here. It's the same matrices. That's okay. I'm gonna write it down. And then you would, of course, hit A inverse times B, and it spits out the answer that A inverse times B equals this matrix. Negative 4, 2, and negative 20. So, D, capital D equals negative 4, capital E equals 2, and capital F equals negative 20. That work gets us to the point where we can do what we did in example 3 yesterday. So get that down. I'm going to have to erase the top, and we're going to rewrite our single equation. Now we have one equation now. And then we're going to have to separate that equation so we can complete the square on it so we can get it into standard form.
So every single time we get a problem like this, it's going to take us the entire class period?
Well, that's, if you get it in this way, that is, if you get it in a way where you don't have 2 points that are really obviously opposite through the center, sometimes you will get that, sometimes you won't. That's why we graphed it first to check and see if we got that. If you don't, then yes, you're gonna have to go through all of this, which takes time. Yes?
Since I know how to do the second part, can I go ahead and just...
Are you sure you're good with it? Yeah.
Thank you.
Remember we had x squared plus y squared plus dx plus ey plus f equals 0. And all we're going to do is put in d, e, and f now. So now we've got x squared plus y squared plus negative 4x plus 2y plus negative 20 equals 0. And from there, it's example 3. So add 20 to both sides and rearrange. So I've got x squared plus negative 4x plus y squared plus 2y equals 20. And then we can have our side work over here. So we have half of 4 all squared. That's that 4. Half of 4 all squared is half of 4 is 2, so we're doing 2 squared. So we want to do plus 2 squared and minus 2 squared for that one to complete the square. We're completing the square for the x terms.
Why does it have to be side work? I can't just do it like underneath it.
Because all I need inside, all I can put inside is the plus 2 squared and the minus 2 squared. So I'm just kind of putting the side work so it can be looked at later. So it's x squared plus negative 4x, and then half of 4 is 2, so plus 2 squared minus 2 squared. And here is the completed square. And then we have to do the same thing with y. So go to the 2 in y, and that's, you need to do half of 2 and square it. Half of 2 is 1, so we're doing 1 squared, so plus 1 squared and minus 1 squared. So that's plus y squared plus 2y plus 1 squared minus 1 squared equals 20 still. And here is that completed square.
Is the 20?
The 20 is what it's equal to, not part of the side. I just ran out of room. But the problem's about to get a lot smaller, right?
Wait, so it was. Oh, I forgot. I forgot what it was.
Okay. So now you take your completed square part, each completed square part, put parentheses, put the first thing, the middle sign, positive or negative, plus or minus, and the last number, without squaring it, remember, and put squared on the outside. And remember, This is the same as this, yes.
So you ignore the middle number?
Not that you ignore it, but it gets eaten up inside of here. If you did x minus 2 times x minus 2 again, you would get this as the answer. You'd get x squared minus 4x plus 1. And then we have this minus 2 squared, which I can now call minus 4. And plus, same thing over here, start with y plus 1 all squared. Then minus 1 squared is still just 1, and it equals 20. Yes?
Wait, so why isn't the second 2 part of the square when the second 1 is part of the square?
Okay, because if you do y plus 1 times y plus 1 again, okay, if you wrote this down, which is what y plus 1 squared is, right? And you went through the process of getting an answer, this would be the answer.
I'm asking because that 2's not the bracket.
This, right, oh, yes, I'm sorry. That 2 is not a part of the completed square.
But the 1 is.
The minus 1 here is not also, is not either. Both of those had to be left out. And all we do is add them in now that we've dealt with completing the squares. So add 4 to both sides, add 1 to both sides. That way I'm getting rid of the minus 4, getting rid of the minus 1. I'm doing negative 4 plus 4, negative 1 plus 1, and then I gotta do plus 1 plus 1 on the other side of the equal sign. So then I'm able to write the quantity x minus 2, all squared, plus the quantity y plus 1, all squared, equals 25. And this is in a form where we actually can see the center and radius. Or we can see the center and we can figure out the radius. We don't actually have the radius sitting in front of us, but we can figure out the radius. So what is the center?
2, -1.
2, -1. And what is the radius?
5.
5. And that's it. This one's done.